Looks like you've made it to part 3 of the Bicopter assembly series. In this video, we're going to focus on our electronics preparation, as well as the installation and basic configuration of INAV. I'm going to begin with the necessary components. We'll be using two 2216 1250 kV Sunny Sky motors. I recommend that you buy the short shaft version, however, you can still use the long shaft version, but we'll need to trim the shaft. Next, we'll need a flight controller. In this case, I'll be using a Maytech F722 wing. I actually wouldn't recommend that you buy this flight controller today due to the flash limitations. However, you can use a Maytech F405 wing or F765 wing. Both will work just fine. We'll need two 30 amp ESCs. In this case, I'm going to be using some BLHES ESCs from Race Day Quad, along with a 470 microfarad 35 volt capacitor. If you plan to operate the Bicopter only on 3S, then the capacitors usually won't be necessary, however, they will be required for 6S operation. Next, you'll need the receiver of your choice. In this case, I'll be using a FreeSky XM Plus, but I'll plan to upgrade to Crossfire in the future. Though I'm still working on stable GPS position hold and autonomous flight, if you're interested in these features, you'll need a GPS. In this case, we'll be using a BN880. And if you'd like telemetry, I'd actually recommend that you go with a receiver protocol like Crossfire that has it natively, though in this case, since I don't have Crossfire yet, I'll be using a 3DR radio. If you're interested in FPV, you'll need a video transmitter, preferably with smart audio, and a camera. In this case, I'll be using a Cadex Beetle V2. I got this actually off of my Eachine Tyro that broke. I printed a little case for it, but any other mini camera that uses a 19mm mount should work just fine. And for the VTX, this is an AKA X2 with a smart audio, pretty janky, came off of an old quad, but still works just fine. As far as wiring goes, you may need to extend wires for certain components. For example, the GPS will need 10 inches of wire, 6 inches for your video transmitter, 5 inches for your camera, about 8 inches for your receiver, about 6 inches for the 3DR radio if you're going to use one, about 6 inches for your ESC signal pigtail, 3 inches for your ESC power wires, 4 inches for the motor connection to your ESC, 3 inches for the main power input wires, and about 4 inches for your motor wires. Some helpful tools to complete the build are going to include a soldering iron, some solder, 24 gauge hookup wire, a Dupont Connector crimp kit, some calipers or a ruler for measuring, and some wire strippers. If you prefer to just solder all your connections and don't really care about modularity, then you can do away with the Dupont connector kit. Some other helpful tools include a flathead and Phillips screwdriver. Our first step will be removing the top plate of the flight controller so we can solder all of our Dupont pins. Like I said in the last step, if you're not interested in crimping and just want a permanent connection, you can skip that step. However, we'll still remove the top plate so we can solder our power wires. Once removed, don't forget to also remove these 4 little spacers to avoid them falling off and inevitably getting lost. Now we can grab our pigtail and soldering iron and complete the connection for the main power wires here, putting the red wire and black wire into the corresponding positive and negative. I'll also make sure to put a link in the description to where you can get these pigtails already pre-connected, as well as the bullet connectors for the motors. And once complete, your joint should look something like this. Next, we can prepare our ESCs by soldering on the capacitor, power wires, and motor wires. When installing the capacitor, pay special attention to ensure that the band with the negative stripe goes on the ground side. If you install it backwards and power it on, you're going to have a bad day. Once positioned, the capacitor should look something like this, then we can solder it. Oh, and one other remark, if you're using a cheap soldering iron like this, that especially only has 2 prongs going into the wall, it's not a bad idea to add a wire that touches to the element to ground the iron, because some irons can have floating voltages which can damage microcontrollers. Once complete, we can go ahead and clip off the excess. Once again, we need to ensure that the side with the stripe is connected to ground. Next, we can solder our signal pigtail, our motor wires, and power wires. Once complete, your ESC should be looking something like this, with the motor wires on one end and our power and signal wires on the other. Now we can repeat this Again, same steps for the second ESC. Once complete, your ESCs should look like this. We can now take some heat shrink and cover them up. Before covering up the ESCs, it's always good to make a little inspection just to make sure there's no solder balls or anything that could be causing shorts. This looks pretty good, so we'll go ahead and seal it up. All said and done, these are our final ESCs. We can now move on to soldering the power wires of our ESCs onto the flight controller. Once complete, we should have something looking like this. Next, we can take a quick inspection to make sure there's no stray solder balls, then cover our barometer over here with a little bit of non-conductive foam and replace our spacers and cover. Now that our flight controller and ESCs are all put together, we can put them aside and start working on our GPS. The original GPS wire is less than 10 inches, so it's too short for this application. I could extend it, however, I think it'd be better to just solder some new wires straight onto these pads that are long enough. So that's what I'm going to go ahead and do here. I've prepared 6 segments of 24 gauge silicone wire that are 10 inches long, and I'm going to go ahead and solder. And once complete, you should have something like this. For this next step, we're going to go ahead and prepare our Dupont connectors. If you don't plan to use any connectors, you can go ahead and solder the connections into these corresponding places. For the F722 wing, our receiver will plug into UART2 here on RX2 and TX2. Our telemetry, if in use, will plug into RX1 and TX1 on UART1, and our GPS will plug into UART3 on RX3 and TX3, along with our compass on the I2C port here with SCL and SDA. Our camera will plug into the bottom right corner where you see C1 and VTX. With these places in mind and the configurations, we can go ahead and prepare our connectors. Or, like I said, if you're soldering, you can go ahead and solder your connectors. If you solder the GPS on the GPS and the flight controller, you'll need to make sure to put the GPS in its mount prior to soldering your connections on the flight controller. For other flight controllers, such as the Matek F405 and the F765, you'll need to refer to the pinout on Matek Systems' website in order to create your connectors. Once complete, we should have a handful of nicely firm connectors. Now we can actually install the connectors onto the wires. For the GPS, we'll need a 6-pin connector. For the telemetry, we'll need a 4-pin connector. For the camera, we'll need a 3-pin connector. For the VTX, we'll need a 3-pin connector and one single 1-pin connector for our smart audio. This connector pattern specifically applies to the F722 if you're using a different flight controller, such as the F765 or F405. Your connectors will need to be different as your wires will be going in different places. Once again, refer to the schematic pinout for where to place your connector. Once complete, you should have the correct bundle of cables for your flight controller. Now we can move on to installing INAV. We'll need a USB to plug in the flight controller into the computer, and then we can go over into INAV here, down to the firmware flasher section. We can select our board, which in my case is going to be the Matek F722 SE. That will be the target we'll be using. And for the firmware, you'll want to choose the newest stable version, which in my case is going to be 4.0.0. Since the board is not in DFU mode, we're going to want to make sure that the no reboot sequence is not toggled and that full chip erase is toggled. We can go ahead and load the firmware online and then attempt to flash. If communication fails, like we see up here, we can enter the board into DFU mode manually. We can do this by physically pressing a DFU button while plugging in a USB. Once you put the board into DFU mode, you should see DFU pop up here in INAV. If you don't, then there may be a driver issue, which can be fixed by installing and running Impulse RC Driver Fixer. Once Impulse RC Driver finishes, we can go ahead and reboot INAV and attempt to flash the firmware again, but this time with the no reboot sequence turned on, as our board is already in DFU mode. Once INAV installs, we can go ahead and connect and enter into the firmware configuration. We'll see the default values menu. Here we can just select mini quad with 3 to 7 inch propellers. Once it reboots, we can go ahead down into the calibration tab and begin our accelerometer calibration. For this step, we can follow those instructions on screen, and I recommend starting with the upside down calibration, as that's the hardest one to complete, in my opinion at least. This one's going to be a little bit off screen here because of the USB cable, but it's important to hold it as stable as you can while the calibration is completing. We can then continue by repeating the process for every other position. Once the calibration is completed, we can go ahead and save and reboot. Once rebooted, we can go ahead and enter the mixer tab and configure our mixer. We're going to want to keep the platform configuration as a multi-rotor and the mixer preset as quad X. There's no need to load the preset, as we're going to create our own. For our motor mixer, we're going to want to add 2 mixer rules, with throttle should be 1 on both here, the roll should be 0 along with the pitch, and the yaw should be 1 on top and -1 on the bottom, so we can have yaw stability with the motors. Later, we're going to test this and ensure that this is the correct direction. If it is backwards, we can simply reverse it by making the top one -1 and the bottom one 1. For our servo mixer, we're going to want to add 2 mixer rules, one for stabilized roll and another for stabilized pitch. We can label those servo 0 and 1, or whatever numbers you would like. We're going to keep the weight at 100% and ensure that they're always active. We can now go ahead and save and reboot on this section as well. Now we can move down to the Outputs tab. Here we'll want to enable motor and servo output. And in my case, I'm using BLHeli-S ESCs, so I'm going to select D-Shot 600. However, if you're using different ESCs, you can select whatever protocol is corresponding. We can set our servo refresh rate to 330 Hz since we're using digital servos that can handle that speed. Motor idle power can be kept at 15% and poles can be kept at 14. We can now come down here and save and reboot once again. Once rebooted, we can now go down to the Ports tab. In the Ports tab, we don't want to touch the first one, as that is our communication for our USB between our computer and the flight controller. Our second one, which is UART1, which is what I connected to telemetry in my case, I'm going to go ahead and leave on MSP data. However, I'm going to change the baud rate to 57600. For UART2, that's where our receiver is going to be. Looks like that's already pre-configured for us. For UART3, that's where we have our GPS. So we're going to go ahead down to Sensors and select GPS. UART4 in my case is what I'm going to use for smart audio. So I'm going to go to Peripherals and select that as TBS Smart Audio. Now we can save and reboot. Once rebooted, we can go down to the Configuration tab. In the Configuration tab, we're going to go ahead and select our magnetometer, which is going to be HMC 5883. We'll go ahead and enable our GPS and our ground assistance if you'd like. And we'll save and reboot. Once rebooted, we can go ahead and unplug our flight controller and install all of our peripherals to test. And something else to take note of is for smart audio, the only connection that will be necessary will be a TX connection to your flight controller on whichever UART you selected. In my case, it's going to be UART4. Also, it's important to make sure your camera can handle 9 volts if you want to plug in power here. If your camera cannot handle 9 volts, like my camera here, it's important to ensure that you plug it into a 5-volt port elsewhere. Our ESCs will plug in to our servo 1 and 2 ports here. Once all is plugged in, we can go ahead and make sure there's nothing that could be touching and possibly shorting. Then bring in our battery. In this case, I'm going to be using a 6S setup. There's two 3S 2200 mAh batteries with a series plug. but 3S will work just fine, or 4S if you'd like. And we'll try our first plug-in. Fingers crossed, hopefully nothing blows up. Sounds pretty good to me. We got our GPS light here. We got our VTX powered. Our ESC is initialized. Our telemetry is powered. And our receiver is powered. Now you can grab your FPV goggles, or in this case I'll be using the receiver on my computer, and we can test that our video transmitter is working properly. And there we are. Looks like the camera is working great. Now that we've confirmed our camera's working, we can go right back into INAV real quick and confirm our other components are working. Now back in INAV, we can look at that top row there and confirm our gyro, accelerometer, magnetometer, barometer, and GPS are all working and seem functional. There is some other calibration necessary, but that's going to conclude it for this video. The last thing to check here is to go down into the Outputs tab. Ensure that there's no propellers on your motors and that they aren't going to move around too much. So I'll hold them in my hand here. I'm going to go ahead and turn on live motor mode and quickly spin up the motors real quick. Ensure they're working. They spin up nicely. Sweet. And that's going to conclude part 3 of this series. Thank you very much for watching. Make sure to stay tuned to part 4, where we take all of this and put it onto the frame of the Bicopter. If you have any questions, make sure to leave them in the comments below. Don't forget to like and subscribe. See you in the next one.